So in this problem, we're going to continue to talk about the titration of a weak acid with a strong base. This is a monoprotic titration, and I was giving you some information last time about what the curve would look like, how we would solve the problem at each point along the curve. And I gave you this general information where you start with 100 mils of 0.2 molar, weak acid, HA, and we titrate it with 1 molar potassium hydroxide. So now we're going to start solving for the pH, starting first with this point here, before we add any hydroxide. In other words, this is just the weak acid alone, or you react it with water. Both of those are weak, or this is a two-way arrow, and the equilibrium constant is the Ka value. Because it's a two-way arrow, it's an equilibrium table, and we use molarity. Hydronium dissociates to form A minus, HA dissociates to form hydronium and A minus. And we're told that the initial molarity is 0.2 molar. It's still that same molarity because we have not yet mixed anything with this acid. Water's a liquid. These start at 0 at the instant at which they're mixed. And we make an X amount of hydronium, which is going to make an acidic solution. So now any equilibrium problem is solved using the equilibrium expression, or 0.2 minus X. Here we'll give the Ka. And we were told in the information above that pKa was 4. So to get the Ka, it will be 10 to the negative pKa, or 10 to the negative 4. Just doing the anti-log there. So now to solve this, you can do the quadratic. That's the safest way to do so. And the quadratic is going to give you an X value and that X value should be 0.00447. And finally, the hydronium concentration is X. So the pH is the negative log of X, which is 2.35. And that proves we have a weak acid alone, right? It's confirmed by an acidic pH. Not only is that pH less than 7, but it's also less than the pKa. Because we know on this curve, we are not going to arrive at a pH equal to 4, the pKa, until the buffer region, and the midpoint of that buffer region. And we've now found this first pH value. So it starts out quite acidic before we add any strong base. Okay. So during a titration, the first problem is no different from other monoprotic weak acid or base problems you've done in the past. You simply act as if that acid or base is alone in water. Set up your corresponding equilibrium table, solve your equilibrium equation with a quadratic, and get the pH. So in a later video, we'll talk about ways to solve for the pH after some hydroxide is added. But for now, for more practice on this, you can visit Unit 1 of my analytical course guide, or Unit 2 in the acid-base section of my Gen Chem course guide at chemguides.com.